Hey guys, Nitro here. In today's video we are going to learn how to do a lookahead system that is usually found in side-scrollers and 2D games. So basically what a lookahead system is that when the player is going to move, the camera is going to go a little bit ahead of our character so we can see in front of him or behind him. So when I'm going to press A, my camera is going to go ahead on the left side, and when I'm going to press D, it is going to go ahead on the right side. When I'm going to press W, I'm going to jump and it is going to go ahead upwards. And now let's see what happens when we combine A and W or D and W. Basically, those two positions are going to get combined and it is going to smoothly transition. And that goes for literally every direction. I haven't set up the S button, but of course if you have like a crouch thingy, you can do that. So now let's see how to set this up. First we will need to go into our player's character, and that for me is going to be the side-scroller character that comes with the side-scroller template. And also, before starting, I want to say that this system should work with the Paper 2D plugin as well. So even if this is just a 2D character, a sprite, it should work. Okay, now what we'll have to do is add a new spring arm. And we'll have to set the target arm length to be 0. And we will have to disable inherit, pitch, yaw and roll. Okay, and now we will need to add some scenes, which are basically empty actors. So, scene, I'm going to name this upwards. Okay, and I'm going to set this on the z-axis 200 units. And I can also add an arrow, so I'm going to have a visual representation of my scene. So let's say here an arrow. And I'm going to point it upwards, and I'm going to uncheck hidden in game. Then I'm going to add a new scene, and this is going to be left, and this is going to go, I think, 300 units on the X axis. Actually no, 300 units on the Y axis. And then I'm going to add an arrow for this as well. Okay, and also uncheck hidden in game. And then we need one more scene. So make sure that these scenes are attached. So one more scene. And this is going to be right. And this is going to be minus 300 units on the Y axis. Also one more arrow for this one. And uncheck hidden in game. Now let's play. And as you can see, now we can see our arrows, and let me explain something that we did in our spring arm. So here, first we set the target arm length to be 0, and that is because I don't want this to have a distance, right? So usually spring arms are used to have a distance from our character. Even our camera right here uses a spring arm, and basically this is the target arm length, 500 units. If this would be 100, it would be much more closer. Okay, so back to 500. In our secondary spring arm, we also disabled inherit, pitch, yaw and roll. And that is because if we would enable this, all of our arrows would get rotated, which is what we don't want, because that means that the location and direction of our arrows will always change and they will not help us later in the blueprint. But there is one more small problem that we might have to fix. There's a chance of us needing to rotate on the z-axis our secondary spring arm. But for now, let's just see how the blueprint is going to react to this rotation, and if we really need to rotate, further in the video we are going to do that. So now let's go in the event graph. This is the default event graph for the side-scroller character, and in here I'm going to get event begin play. And I'm also going to get a set timer by function name. And this is going to loop a function every 0.1 seconds. But first we are going to need to create a function. So we are going to add here a custom event, and then going to call this camera movement. And I know this says function name, but this will also work with custom events. So we can just copy this name and paste it in here. So now every 0.01 seconds, this custom event is going to be called or fired, however you want to say that. And here we will need to have a sequence, because we are going to do two pieces of script. So now let's just take care of the then 0. First we need to create a new variable, and I'm going to call this key combination. And I'm going to make this a string. And what we're going to do here is a little bit of hard code, but it should not be a problem because it's not going to be too big or too complicated to understand. And then it's also going to be pretty easy to edit later in the blueprint. Let's say we want to have the arrows and not WASD, you can just edit those. Alright, so now what we'll have to do is to get here a branch and get player controller. Then we are going to get isInput key down. So let's see, isInput key down. And we're going to check if our A key is pressed or not. If that is true, we are going to do something. But if that is false, we are going to do another branch. And here we are going to check if our D button is pressed. And if that is false, we are going to do another branch, which is going to check if our W button is pressed. Let's compile. And now from the top part, from true, we are going to do another branch, which will check once again if the D button is pressed. Okay, now let's compile and let me show you why we'll need to do this check. If I'm going to press A, I'm going to move on in the left direction, but then if I'm going to keep pressing A and then I'm going to press B, my character is going to stop. So that means that the A button is going to be pressed, and that is what the function is going to first check, if the A is pressed. But then I also want to check once again if the D is pressed, because if that is false, so only the A is pressed, we are going to set the key combination to be A. Now if the D button is pressed, we are going to set this to be D. And if the W button is pressed, we are going to set this to be W. And if even this is false, we are going to set this to be nothing. That means that we are going to leave this empty. Alright, and the reason why here we are not going to check once again for A is because we have already checked this right above it. Okay, and now if this is true, so both A and D are pressed, we are going to check if our W key is pressed. So we are basically going to check if at least W is pressed, and if that's not true, we are not going to have any spatial camera movement. Okay, but now currently you can see that we have no combination of A plus W or D plus W. So what we'll have to do is to delete this, and we're going to do two new branches for both. And here we are going to check for both if W is pressed or not. So we can just copy this, put this in here, and if that is true, so both A and W are pressed, this is going to be AW. If only A is pressed, which means that this is false, we are going to have A. If both D and W are pressed, we are going to have here DW. And if only D is pressed, we are going to have only D. And now let's compile, and now we will need to take care of the sequence of the then1 from sequence. So I'm going to move this to the side, and I believe we can even collapse this to a function, and I'm going to call this check keys. So this way our blueprint is going to be a little bit more clean. It's going to be cleaner. And now from then1 we're going to have here a switch on a string. So basically this is like doing a lot of branches, but we're not going to do a lot of branches because that's non-performant, and we are going to get a switch on string. So basically what this is going to do is to check if the value in key combination is going to be equal to any of these pins that we are going to set. So let's set for pin 0, it is going to be A, as you can see. So if the key combination is equal to A, this pin is going to be executed. If key combination is equal to D, the second execution pin is going to be executed. Then we're going to check if W is pressed. Actually, we could get AW, and then we're going to get dw, and then we're going to have one more that is going to be w, so just plain w. Okay, so now let's set this up, and what we'll have to do from A is that we are going to get a sequence, and we will need to first set up then 1 and then 0, and this code is going to get a little bit messy, and that is because we cannot collapse anything to a function or make a custom event, unfortunately. So from then 1 I'm going to add a timeline, and I'm going to name this A. And let's set up this real quick. I'm not going to set a new track, I'm going to add a new key, time 0, value 0, time 0.5, and value 1. I'm going to make the length 0.5, and let's fit both in here. And now the reason why we are going to do this from 0 to 1 is because we are going to use this as an alpha to a lerp vector. So here lerp vector, and let's plug this in alpha. And what we'll have to do, what we're going to set is the socket offset of our camera, the spring arm of our camera. And the socket offset is basically the position that our end of the boom arm is going to have, or spring arm, however you want to call it. So if I'm going to set the X to be, let's say, 50, you can see it moving. Or if I'm going to set the Y to be 150, you can see it moving to the right. So back to 0. In event graph, I'm going to plug update in the set node, and the return value of the lerp vector in the socket offset. And now the B is going to be one of the locations of our scenes. But let's see, A is the left key from our WASD keys combination. So we are going to get the left scene, we are going to get relative location, this is going to go into B, and then for A we are going to get socket offset. And now this should lerp between these two vectors. So basically what's going to happen is that this is going to lerp from 0, 0, 75 to the left, which means 0, 300 and 0. But because we already have 75 on the z-axis for our spring arm, we can also set here 75, and that goes for the right scene as well. 75, okay. And now what we can do is to have here a custom function called stop. So add custom event, and I'm going to call this stop timeline underscore A, and I'm going to plug this in stop. I'm going to have here another custom event, and I'm going to call this stop camera movement. Okay, and I'm going to call stop timeline A. There are going to be multiple custom events in here, but first we need to set them up. So for D, AW, DW, and W. Okay, let's compile. And here from then 0 we will need to call stop camera movement. Okay, let's see. And if none of these are pressed, what we'll have to do is to have here a new sequence. We are going to call stop camera movement. I'm going to explain what is happening in here a little bit later. So a new timeline here, add the timeline. I'm not going to call this timeline. I'm also going to have a custom event. So add custom event stop timeline 0, and I'm going to call it in here, called stop timeline 0. And this should have the same properties as the last timeline had. So time 0 and value 0, time 0.5 and value 1. Okay, and now we can just copy this setup in here with some changes. This goes in here. Okay, new track in alpha. And what we'll have to do is to, so the socket offset is going to be A, and B is going to be a custom vector that we are going to set up. So vector, make vector, and it's going to be 0, 0 and 75. Okay, now let me explain what happens. So basically every 0.01 seconds we are going to check what keys are pressed based on our WASD combination, and we are going to get A, W, D, AW and DW. And if I'm going to press A, what it's going to do is that we are going to stop all these timelines. So we are going to have like 3 or 4 more timelines, and we are going to stop all of them here at some point once we are going to create them. And then we are going to lerp from the spring arm offset value to the relative location of a desired scene. So this should be pretty easy to understand. So no matter what the socket offset of our spring arm is going to be, we are just going to lerp it somewhere at one of these scenes. But if none of those scenes, if none of our keys are pressed or the combination is not working because it's not the right combination, we are going to set it back to its default value. And now let me explain why we are going to stop all these timelines every time we are going to fire one of these pins. So basically, if we were mid timeline, so let's say 0.25 seconds in this timeline, and we would press A, 0.25 seconds, and then we would press D while this is going to run, we would have 2 timelines running at the same time, setting the same value at the same time, which would give us a bug, which we don't want. So we're going to make sure that we stop all these timelines. So no matter which key is pressed, we are going to stop them, because we want to make sure that none of them are running at the same time of any of these. And we are going to run just only one timeline, which is going to set the socket offset to be at some location of these scenes. And why this is working, the reason why this is working, even though we have stop camera and then timeline 0, is because sequences are going to run actions in an order. So first it is going to have then 0 and then 1. If this would be, the timeline would be then from then 0 and the stop camera movement would be then 1, this would not work. So make sure that you don't get this wrong. It's really important to make sure that you got the right order. Now let's try this out. So as you can see, for A it is working indeed, but it's going the wrong way. And also, at some point, as you can see, it will just snap. Let's see how we can fix the snapping problem. First is that we will need to go, and instead of displaying, we will need to play from start. That means that we're just going to connect then 1 and play from start. And now, as I said, there is a chance of us getting problems with our scenes. And let's see what happens if we go to the left scene here. The Y is 300, and let's go to the spring arm and set the socket offset to 300. As you can see, the left for this guy, so 300 for this guy, is on the right side and not on the left side. What we'll have to do is to go to our relative location, split the struct pin, get the Y axis, float multiplied by a float, -1, then make vector, X in X, Y in Y and Z in Z. Okay, and this should go in B. Now let's play, and as you can see, it is indeed working. And now what we have to do is to set this for all the other axes. So what we can do is to copy this, and we are going to get some errors, but it doesn't matter, we are going to solve them right now. So first we need to rename this custom event. We're going to call this stop timeline D, and I'm going to call this timeline D. Okay, and now let's see what we have to do is we need to, instead of left, we need to get right. Okay, and here we will need to call stop timeline D. Okay, and now this is pretty straightforward. You just need to copy this once again for each input. Okay, now this is AW. I'm going to name this stop timeline AW, and here this should be AW. Okay, and that means that we will need to set a Z for this one as well. So what we'll have to do is to get the upwards scene, get relative location, we are going to split the struct pin and we are going to plug the Z in here and not the Z from the right scene. But also we will need to get the left scene and not the right one because A is located on the left side. Okay. And now we can also set here call stop timeline AW and also rename this timeline AW if you haven't. So once again, DW stop timeline DW. This goes in here. Call stop timeline DW. Okay, and now we should get here right and not left. The last thing we have to do is to copy the first one once again. Okay, make sure that your blueprint is not as messy as mine, because it's not going to be good. Okay. And now what we have to do is to rename this custom event once again, stop timeline W, set the timeline to be W, get here upwards scene, and I don't think we have to do anything in here, we can just delete this, recombine the struct pin and set this in B. Now let's play and let's see if this is working or not. So play, A is working, D is working, W is working, actually no it's not working, and let's see why. Oh, I think I accidentally deleted the vector here. No, there's something wrong in here that we need to fix. Let's see what exactly. So upwards, set to 100, 75. So we could eventually print your string with the return value, and let's see what's going on. Okay, for 0.2 seconds. So let's see, press W, and it seems that it's not even working, and that is because I forgot to connect this up here. Okay, now this should work. As you can see, it is indeed working, so I can delete this print string because we don't need it. Okay, so as you can see, W works just fine. But there's actually one more thing that we have to do in our blueprint, and that is to add here call stop timeline W. And this is everything that we have to do. Now W is going to work perfectly. So this is pretty much everything for today's video. I hope you enjoyed this tutorial, and if you did, don't forget to leave a thumbs up. And if you're new to the channel, don't forget to subscribe to stay up to date with new videos. Also, if you'd like to get the project files from this tutorial, you can support me over on Patreon for as little as $1. Thanks for watching, and I'm going to catch you in the next one. Goodbye.